right, we're going all the way back to Great Britain now, back again to Great. In fact, this is going to be the invasion of the British week, I think, tomorrow night as well. John Gribbin was born in 1946 in Maidstone, Kent. He studied physics at the University of Sussex. 1966 BSc, went on to complete an MSc in astronomy at the same university. 1967 awarded with a very special merit award before moving to the Institute of Astronomy in Cambridge, then under the directorship of Fred Hoyle to work for his Ph.D. During this period, he gained an Isaac Newton studentship for research on gravitational problems and the prestigious annual award of the Gravity Research Foundation in the United States, the only student and the first Englishman working in England ever to receive this award, and so much more. He has written books, one about climate change, one called The Sixth Winter, In Search of Schrodinger's Cat, In Search of the Double Helix, In Search of the Big Bang, In Search of the Edge of Time, Being Human. It just goes on and on and on and on. Obviously, a real heavyweight. And all the way from Great Britain, here is the professor. Professor Gribbin, welcome.
Thanks. It's nice to be with you. I'd forgotten a lot of that stuff. It takes me back.
Does it? I hardly even know where to begin with you. You have written a book on climate change, and there are many of us, Professor, who believe that our climate is actually in the midst of that change right now. I wonder how you feel about it now.
Yes, I'm one of the ones who's convinced is perhaps too strong a word in science. You always want absolute proof before you say something enough to convince a...
Curious, Professor, here in America, there are many who, when they hear words like the ones you just spoke, actually get angry, and their anger comes from kind of a political place because they understand that in order to change, what you just said is now beyond any shadow of a doubt. There would have to be changes that would affect the political world out there, indeed affect all of us. Do you get the same sort of reception when you say that in England?
It's much more acceptable, if you like. I think people have had longer to get used to the idea. My understanding from my travel and talking to people in the States is that over there you've felt as if these things didn't affect you, that technology can solve all problems, whereas in the rest of the world people have perhaps had less faith to start with that we could solve all our problems that way. And so when we're told that there are problems that are arising and we've got to change our lifestyle to cope with them, it came as less of a shock. And it's certainly most of the people that I talk to, I mean, there's a general willingness to accept that there is a problem and something needs to be done. And, of course, the debate then is about what needs to be done and how quickly after the case that something is happening and action does need to be taken.
Professor, can you articulate the range of the change possible both on the hopeful side and on the other side as well?
Well, this is something I haven't looked at for a long time. It's an area that I worked in about 10 years ago, and what happened was that I didn't stop being interested in it. I stopped working in it when the evidence became compelling because I was interested in the scientific side. And once it was clear that there is a problem there, then it becomes a political issue, and I could have spent my life becoming a politician and doing things in that area, but for various reasons I chose not to, and so I haven't been closely involved in the subject for about 10 years or so. Years that come out of people like during the present century of perhaps up to about 5 degrees Celsius, which would be the worst case scenario, and even if things go well, then it will change, but not so drastically.
If things don't go so well and we get a 5 degree Celsius change, people say, well, it's not much. So
no,
what?
It's not much if you compare, summer to winter, and even day to day you can get changes that sort of size. But what you have to do is to look at this as a long-term change in that the average over the whole year, every year, and compare it with things like the changes that warmed the world out of an ice age about 10,000 years ago. And I can't quite remember, I think the figure's about 3 degrees, the average rise in temperature worldwide that made the world change from an ice age to the conditions we live in now is certainly less than what we're talking about. So it's a very big change in terms of the world's natural processes, the ecology, the plants and animals and so on.
What is the likely practical result? In other words, what could the world expect if it experienced a 5 degree Celsius change?
You get changes of all kinds. I mean, some places will get drier, which is what gets a lot of publicity, new deserts and so on. Some places will get wetter, which, in terms of rainfall, which obviously can be a good or a bad thing. And, of course, the rise in sea level that results partly from just the thermal expansion of the top layer of the oceans. It's warming up, so it's getting bigger, and partly from glaciers and ice caps melting. It's going to have a dramatic effect on places around the world, from Bangladesh to Florida. And I think there's been some amusement in some quarters over here in Europe that Florida, being the key state that got George W. Bush elected, is likely to be the first part of America to suffer detrimental effects from his policy on climate change.
God's work?
Well, who knows?
No? All right.
I guess Jeff might have something to say about that.
There will be people living on islands around the world that I suppose will be with the fishes, right?
Yeah, absolutely. There are some small islands, particularly in the Pacific Ocean. There are a lot of small islands which are only a meter or so above sea level. It's just going to disappear.
Actually, there's one, I believe, in the Pacific that is rather sinking at the moment.
Yes, well, you've got 2 problems. Of course, some of these places are literally sinking because of geological processes. But what's happening as a result of this global warming is that the sea level is rising. And I should say, often when I talk to people who haven't got scientific background, global warming is a reality. That's something we can measure. The temperature's going up. And then this business about the greenhouse effect and human activities is where we say, well, how much of it's caused by human activities, how much of it's a natural process. And a lot of people think the words global warming mean that human activities are changing the climate. They're not synonymous. The world is warming up. How much of it is due to our activities, we can't quite be sure.
It could mean, though, another ice age. We don't know exactly what it's going to mean.
Well, all kinds of things could happen. I mean, one of the scenarios that concerns people in our part of the world, in northwest Europe, is that we're kept warm by the Gulf Stream, which a current that flows up past Florida and sort of turns right at New York and comes across the Atlantic and brings warm water to our part of the world.
Yes.
And that brings warm air, which blows past and keeps us a lot warmer than Alaska and Canada, which is the kind of temperatures we ought to have. And it's possible that the changes in the amount of fresh water getting into that part of the world from the Arctic Ocean as the ice caps melt could change this current, and Europe could get colder while the rest of the world gets hotter. So there are all kinds of complications that we just can't calculate in detail yet.
So you could...
Moisture into the air is bad if you're in a cold part of the world. So while these changes are going on, obviously warmer water evaporates more, so you get more clouds, you get more rainfall or snowfall, whatever it might be. So extreme weather events in a warmer world, and more hurricanes, and they would extend further north up the Atlantic seaboard of the States, for example.
Well, yes. As a matter of fact, now I saw on the cable news network here that the meteorologists are beginning to, actually, for about the 3rd time, modify their opinion of how strong the hurricanes are going to be this year. They're really getting worried about it because of the heat. In the amount of heat in the Atlantic.
Absolutely, yeah. I mean, hurricanes are driven entirely by warm water. That's why they only happen in the tropical regions, and they need a certain temperature to keep them going, and that's why they peter out. Obviously, if they go over land, they peter out because they run out of water to draw on. But even over the oceans, as they go away from the equator, where the water gets cooler, they fade away and they become only severe storms. They're still bad enough by human standards. So if the oceans are warmer, you're going to get more of these storms, they're going to be stronger, and they're going to extend further away from the tropics, yeah.
All right, Professor, you sort of ducked out as this became political, obvious to you that it was underway and it became political, and you have concentrated in the world of physics. There is no thing that I am personally more interested in the whole world than time travel. I obsess, actually, about the possibility of time travel. And I know that you've written about this, that you know something about it. And so the first question that I would ask you is, in your opinion, is time travel going to be allowed by the laws of physics as we know them now, or as we imagine, some of our theoretical physicists imagine they may be?
Well, the short answer is yes. And there's nothing in the laws of physics, as we understand them, which prevents or forbids, if you like, time travel.
Really?
The long answer is that it will be very, very difficult and involve manipulating huge amounts of mass. I mean, much more than the mass of our sun, for example. But it's one of the most exciting discoveries to theoretical physicists of the past 20 years or so, is that there is nothing which prevents time travel according to the equations of physics as we understand them.
Nothing that prevents time travel.
That's right. I mean, it's not saying that time travel is definitely possible, and it may be that we will discover a law which does prevent it later on. But it's the two areas of physics that came out of the 20th century. The two great discoveries are the general theory of relativity from Einstein and quantum physics from a whole load of people who developed that. And from those two theories, those two sets of mathematical equations seem to describe everything in the physical world that we've been able to probe with our experiments. And it's those two sets of equations that tell us that it's not impossible certainly for particles to travel in what we call closed time-like loops. That means loops in time going back to where you start. And once you start talking about particles being able to do that, then it's natural for you and me and everyone else to speculate about human beings or spaceships or whatever doing
Would you think, Professor, that travel in time forward would be equally possible with travel in time to the past?
Well, travel in time forward is easy. I mean, it's something that, I mean, in a naive sort of sense, we do. I mean, we move forward at 24 hours a day, all the time, without even trying. And it's something that is easy to do within the framework of the theory of relativity by traveling fast. If you travel close to the speed of light, then in a sense time slows down for you, and so you get into the future quicker, and you could go on a journey in a spaceship, and come back, and it would seem like a week had elapsed for you and maybe a month had elapsed on Earth. So you would have traveled into the future in that sense. Getting back has always been the hard problem, and that's what people are excited about and interested in, is the possibility of going back in time.
So it would be, in your opinion, far more difficult technically to achieve going back.
Absolutely. That's where you start talking about these huge concentrations of mass, and there are things, I think you've probably had people like Michio Kaku talk about this on your program before, these cosmic strings.
That's right.
Where you have tubes of material with fantastic energy density that distort space and time in their vicinity. And if they exist in the universe, as many people think they do, then they could act as a kind of natural time machine, and you could travel back in time by finding one of these objects and flying around it in a circle.
Are you referring to the event horizon of a black hole or a wormhole?
It's very similar. You have they affect space and time in a similar sort of way. But that's the other aspect, is this idea that you could use a black hole as a gateway to a cosmic subway and travel through it and come out somewhere else, which, of course, Carl Sagan described very memorably in his novel and film Contact. That stuff in that science fiction movie is real science, in the sense that it could happen according to the laws of physics, but it's as difficult. The analogy I always like to make is, you go back to someone like Leonardo hundreds of years ago designing a helicopter. He could never make it fly. We're almost in the stage now where we can design a time machine, but it'll take the technology of hundreds of years in the future to make it work.
Actually, Contact, the movie, is one of my favorite movies. I've watched it again and again. That's if you hear the little phone number bumper I've got in the beginning, you'll hear, "Want to take a ride?"
Right.
Well, I lifted that right from that movie, believe me. So that movie, then, technically was roughly, hypothetically, accurate.
Yes, it was. I mean, there's a wonderful story about this, which if you're a fan of the movie, you probably know. But what happened when Carl Sagan was writing the book was he wanted to use this idea of traveling through this sort of cosmic subway space machine, if you like, to travel from one part of the universe to another. And he wanted to dress it up properly with some mathematical bits and pieces. And he's a planetary scientist. He didn't know much about the relativity, and he asked a friend of his, Kip Thorne, to work out some mumbo-jumbo, not real maths, to put in the book to disguise his lack of knowledge. And Kip went away and thought about this for a weekend or so, and he came back and he said, "Well, look, Carl, actually, this isn't mumbo-jumbo, this is real. I mean, Einstein's equations say you really can travel through these tunnels in space. And then a little bit later, the penny dropped, and I think it was one of the students in Thorne's group who said, well, Einstein taught us that space and time are the same thing, and if you can have a tunnel through space, then you can have a tunnel through time as well.
Indeed.
And that led to, I was going to say an explosion. I mean, it's actually about 24 people, but it felt like an explosion of interest in the late 1980s, 1990s in the scientific community.
All right, Professor,
this stuff.
I've got to ask you to hold on for a moment. We're at the bottom of the hour. We'll be right back. This is Coast to Coast AM. Back to Professor John Gribbin in Great Britain. Professor, it's way away from your field, but it just happened a week or so ago. This incredible Wiltshire crop circle, 409 circles. It just does not seem possible that a man could have done this, certainly overnight. Have you had an opportunity to see it yet? Any comments?
I haven't seen that particular one, no. I try to keep an open mind on these things. I think human ingenuity is pretty high, and I would be surprised if there wasn't some way that people could make even something as complex as that. But I've at least a hint of a possibility, I think, that there is a natural phenomenon which produces some of them. I know for sure some of them are made by people. I know some of the people who make them.
Oh, sure.
But you know, that maybe they aren't. That doesn't mean they all are. It doesn't mean they all aren't. And in fact, although it's not in my area, I've used crop circles in a novel that I've written with David Compton, but it's not yet published. We haven't found a publisher for it. So maybe this will stir up interest and we'll get somebody to buy the book.
Well, it looks like most of your series is in search of something or another. Do you have a working title on the new book?
No, we want to get the word time in because it involves time travel as well. So we're thinking along the lines of time ways or something like that. But that's often the last thing to come when you're writing a novel.
Is there, Professor, work going on that you are aware of now on time travel?
Well, there is, in the sense that people sit down and work out with pencils and papers and computers how things might be done. I'm not aware of anybody who's trying to build a time machine, to put it in that sort of language. But there are people who work with changing time, if you like. You may have seen there's been some stories about slowing down light.
That's right.
By passing it through various media and treating it with in different ways.
Yeah, but I'm told actually, Professor, that that is almost a parlor trick. That even though on the one hand you do in effect slow down light, you really don't. That's a good way of putting it. I mean, it's a lot of these things they start out like that. They are parlor tricks, if you like. But again, sort of making the analogy with flight. People built paper aeroplanes before they built real aeroplanes. So you go from the parlor tricks to doing something useful. And one that I always like is back in the middle of the 19th century, James Clerk Maxwell, who's a great scientist who worked with the color theory of light. And he was the person who worked out that you could make color photographs by taking 3 black and white images through 3 different colored filters. That's right.
And that was a parlor trick. He photographed a piece of tartan and demonstrated it in color at the Royal Society in London and astonished everybody. And not much more than 100 years later, the space probes that visited Saturn were sending back color pictures of Saturn using exactly that parlor trick. So don't dismiss parlor tricks.
Certainly not. So what about this? People say that if time travel is ever to be possible, and we all know how quickly technology is advancing, the speed of processors doubling every 18 months, whatever it is, that if time travel is eventually going to be possible, it's easy to imagine it will be. Then where, pray tell, are the time travelers?
The simple answer is that you can't travel backwards in time, according to these same laws of physics that we've been talking about, to an earlier time than when the time machine was built. So if I was to build a time machine in my backyard tomorrow, I could, in principle, travel anywhere in the future and I could come back to tomorrow. But I couldn't come back to today because the time machine didn't exist then. And that seems to be the simplest way around that puzzle. There are people like to speculate about these things, and there are stranger ideas like that perhaps time travel is possible and the world is full of time travelers and they're just hiding from us for some reason.
So then from the very moment then that a time machine is invented that would go into the future, then from that moment we could expect to get visitors
exactly
from the past.
No, only from the future of the machine. The machine can't open up the past of the machine.
So then we would never experience the visitors, would we?
No. What we need to do is to find a natural time machine, one of these cosmic strings or one of these wormholes, something like that. And if you find something that's been around for millions of years, then you can use that to go back to all those millions of years in the past. So there's a better prospect, perhaps, of developing space travel in the hope that we can then find a time machine and use that for time travel. And again, something that's been explored in many science fiction stories, rather than building our own and only being able to travel into the future, if you do think that.
Oh, no, that's very exciting indeed. But once an individual got there, that individual could not come back, short of finding...
They could come back to the time when the machine was built, but they couldn't go back any further.
Any further?
Yeah. And, of course, one of the interesting things about this is it means it would be almost impossible to keep something like that secret, because if you had a huge secret government project and you built the first time machine in some dark and secret place and didn't tell anybody, what that does is it opens up the future. So people in the future who've got better technology than us can then come back to the moment that time machine was built. So your dark and secret time experiment is successful, in some underground laboratory in the middle of the Rockies, and immediately time travelers can come anywhere, and come up to you in the street in New York and say hi. So you're not going to keep this project secret if it's a success. So that's a twist that I guess the government researchers ought to be aware of.
So in other words, and certainly the government, as always, would have an intense interest in such a machine. What would be the practical applications you could imagine of being able to go to the future? And wouldn't it mess things up kind of?
Yes, I think we have to turn to the writers of fiction to look at all the problems that could arise, and they're very similar to the problems of making contact with alien civilizations, which is a much more realistic prospect, certainly, in our lifetimes. The culture shock, it's all very well imagining that you could make some kind of contact with the future, even if it's limited contact, and find out wonderful things and have new technology and stuff like that. But it would be an enormous culture shock, and it could destroy our civilization entirely, the way that some of the civilizations of the Pacific were destroyed by contact with what we call Western civilization.
Actually, I think most of these civilizations untouched, or these groups untouched by modern civilization, have in fact been destroyed by contact, haven't they? Yes,
I think it certainly was something that happened a great deal, and so it's something that's worth being aware of. I say, and people, sociologists, psychologists, and people do look into this from the point of view of what would happen if we got a message from another civilization in space. Just the mere knowledge that we weren't alone, would that be a huge religious experience for the world, or would it destroy our faith in human ability if we knew there was a superior technology? It's possible people might think, well, why bother? What's the point of inventing things if it's all been invented by somebody else?
Well, here's something I don't get. Let's assume that we were able to snatch knowledge, technical knowledge, from 500 years in the future, and it decimates us, decimates our society. We don't know how to handle it. We're not socially prepared for it, whatever it is that we could imagine. What would that do virtually to those who, 500 years in the future, who imparted that knowledge to us?
Right. Well, you're right there in the realm of all the time travel paradoxes, and the classic one working the other way around. If you go back in the past and you do something that can't go back, well, because the quantum physics allows for the possibility of there being more than one reality, that there are different versions of of everything if you take it to the extreme. But in the simple case that when you have particles like electrons and they're given a choice of doing one thing or another, turning left or right when they come to a particular world splits in two, and you have one world in which it goes left and one in which it goes right. And the answer would be that the knowledge and the future that has changed us has changed our future, but that it came from another future, if you like, the future next door. And there was a wonderful book called Timescape. It's one word, so it's kind of a pun on time escape as well, by, I think it was Gregory Benford, which looks at this whole problem. And that's about a project where communication with the future is established, and it does change the world. And once the world is changed, the communication stops because that's no longer our future, it's somebody else's future. So there are ways around all these problems if you look at the laws of physics and you think hard enough about it.
Well, Professor, the way it was explained to me by Professor Kaku was that at the instant, for example, that you killed your father or grandmother or whatever, there would, in effect, be a new universe, a new bubble that would be an entirely different stream of time and events.
That's right. I mean, you can think of it. Another analogy is like with the branches of a tree, and we're sort of traveling up the trunk of the tree, and it's possible, if time travel is possible, to get communication from all the branches above us. But when you do something that makes a decision of the kind you're talking about, that's like turning off into a side branch. And once you do that, then there are still different possibilities as the branch sort of turns into little branches and twigs and so on. So you haven't sort of finally crystallized everything, but you've turned away from one particular path. And so that path is no longer open, and you're heading in a different direction.
Well, Professor, then might it be possible, or would there be any difference, delineation between time travel as we have discussed it, and the possibility of either communicating with or moving to one of these alternative universes?
No, I mean, this is something that there's a guy called David Deutsch at the University of Oxford who looks at these kinds of possibilities. And if you can travel, if you like, sideways in time, then you could move into these other universes and you could experience them and perhaps come back or send communications back and get information. And there's a practical thing which sounds like the weirdest science fiction, but people are taking very seriously. It's a kind of computer which would exist in more than one reality at the same time because of quantum processes going on inside it.
A quantum computer?
A quantum computer, which would, you build one processor, in effect, and you get a vast number, I mean, in principle, an infinite number of processors, because the computers in all the parallel universes would be working on the same problem that you set your computer. So they'd solve it very, very quickly, and you'd get the answer. And this is, I assure you, this is being taken seriously by people who understand the mathematics and the quantum physics much better than I do.
How much farther do you suppose our technological ability will have to go to begin experimenting with something like a quantum computer?
Well, it's already happening in a very, very limited way. I
Really?
mean, we're used to thinking of, your home PC will have, megabytes of memory in it, and people are doing experiments at the level of a few bits, not bytes, 4 bits or so. They're doing experiments to see if they can make this sort of thing work. And there are people I talk to who say that it could, within 20 years, they could have something working if the equations are correct.
Oh,
and of course, you don't need very many bits if you're going to have an infinite number of copies in an infinite number of parallel worlds. So that's all you need, and they are working on it now.
Yeah, just wait till our Bill Gates gets hold of that. So then, at that time, when a quantum computer became possible, would it be possible to have communication with these alternate universes?
Well, that's the big question that nobody's yet been able to answer. I mean, I've seen the experiment and finding out, because the rules of quantum physics seem to say that you can't communicate from one to the other, that they exist. You'd know they existed because the computer would be able to solve the problems and it would act as if it was a much more powerful computer, but that you can't actually transfer information. It's related to the famous uncertainty principle, which says that there's a limit to what knowledge you can have about the position of a particle and things like that. But people are always looking for ways round these rules, and who knows, it might be possible.
If it were possible to travel to one of these alternate universes, would we arrive in a place, perhaps for the most part, pretty much, you would imagine, similar to the one we're in now, except perhaps where events had unfolded in a different way? For example, Germany would have won World War II, and we'd all be under Hitler's boot.
Those are possibilities, yes. I mean, the kind of feeling that people have is that it would be easiest to travel to similar places, if it's possible at all, and that similar places where there have been very small changes, maybe not even as extreme as the ones you're talking about. You know, you'd do the experiment and travel, and you might find it very hard to tell the difference. You know, the difference might be, you know, that a different team had won some football competition, you know, and that was the only difference in the whole world. So it might be hard to tell whether your experiment had succeeded or not with limited abilities of this kind. But what you'd expect is that there be a whole array of other worlds, if you like, getting more and more different the further you went, and the harder it was to get to them. Yeah.
What about the possibility, Professor, that the laws of physics, as we know them in our world, would be not quite the laws of physics in the alternative universe you plop down into?
That's a dangerous line of questioning, because if the laws of physics are different, then the whole basis of your whatever you call it, your sideways time machine, might not work. So you might have designed something that works on our laws of physics, and you get into another world and it didn't work anymore, and nobody would believe you'd come from another world because your machine didn't work. I'm not sure about that. There's another way of looking at all this business about the laws of physics and whether they could be different in some sense in other parts of the universe or in other universes. But I don't know of anybody who's seriously trying to deal with this kind of quantum effect and suggest that there are different laws in the world next door.
But to imagine, for example, you're plopped over there on the other side and you've got a machine. Imagine it like an automobile. You get over on the other side, you turn the key, and you don't even hear the starter grinding or the internal combustion engine even beginning to work, because internal combustion doesn't work.
That's right, yeah. I mean, all these things, this is a whole other area that fascinates me, is why the laws of physics are the way they are. And there seem to be many, if you like, coincidences in the laws of physics that allow life to exist in the universe, which is obviously the most important thing to us. And if there were small differences in things like the laws on which electricity and magnetism operate, the strength of electricity and magnetism compared with things like gravity,
right,
then the world would be a very, very different place, and you wouldn't have the kind of chemical reactions that go reactions inside stars that made the elements that we're made of, and all of that. And so there is a very important question in science as to why the universe should have exactly the laws it does have. And I suppose, from a theoretical point of view, one of the main reasons for doing an experiment to communicate with the world next door in this quantum sense will be to find out if it was possible for different laws to exist and to produce intelligent life.
Or perhaps you would plop down in an alternative universe, and you would land in one in which a human life never evolved.
Yeah, well, you might land in one where our form of life is impossible, and so you drop dead. You know, I mean, it could be as drastic as that.
My. So, if somebody were to develop such an ability to transfer, how would we ever know if it worked?
Well, that's a very, very big question. You only know if it works if you get something back. I mean, if somebody, it's like H.G. Wells. I mean, H.G. Wells' story, The Time Machine, the character in there builds what he says is a time machine, and the story is told from the point of view of his guests, although story he just disappears. Now, the story is telling us that he's built a time machine and he's disappeared into the distant future, but we don't know. People disappear. We don't know where they've gone. You've got to come back. That's the key to the whole thing.
All right, Professor. Top of the hour. I know we've only got you for 30 more minutes. You've got a big day tomorrow, so stay right where you are. We'll be right back. I'm Art Bell.
One in town, of the love that he just found, and the reason of his latest flame.
to us all the way from Great Britain is Professor John Gribbin, and one of the books he wrote is called In Search of the Big Bang. And I want to take a moment and ask the professor, I've talked to so many people about this, and I have yet to be able to grasp the concept, Professor, that something apparently smaller than a quark, something we can just barely imagine the size of, became everything that is. All the stars, all the planets, all the space, all the dark matter, all the whatever it is that's out there, everything we can see and walk and touch and feel was created in an instant, just boom, like that, from nothing. And I know that's kind of where most physicists sort of throw up their hands and say, we don't know. Do you know yet?
Well, we don't know in the sense that we have a definite answer to exactly what happened, but it's one of those examples of progress being made. When I was a student in the 60s, we were told you shouldn't even try to think about this kind of thing because it's beyond science. And now, nearly 40 years later, it's part of science in that people do try to think about it, and they come up with ideas and models and theories about what could have caused that beginning of our universe. Really?
Okay, well, I'd just love to hear some of the leading contenders.
Okay, well, the one is that it literally is something from nothing at all, and that you had this nothing in a very complete sense, in which a little pinprick of energy containing all the mass and energy of the universe appeared. And that's possible because there's a very strange feature about gravity, which is that gravity actually has negative energy in the proper scientific sense. So if you add up all the gravity in the universe of all the things pulling on each other, that gives you a negative energy, which exactly balances out the mass energy, the E equals mc squared that Einstein taught us about, of all the particles and stars and planets and people and so on. So it is possible, virtually certain, that the total energy of the universe is zero. So it's not a question of getting something from nothing, it's getting nothing from nothing. Okay? So that's something that I go into in the book, but it's hard to explain in
that one will make your head hurt a little bit.
But that's good. There's nothing in the universe at all. The one that's very popular now is that the idea that there is some kind of an infinite sea, if you like, beyond our bubble, our expanding bubble universe, that there is a bigger, eternal cosmos, people sometimes say, just to have a different word, in which different bubbles go off at different places and different times.
Bubbles of nothing?
Of energy, yeah, which turns into matter and so on. And that removes the problem of the beginning by saying there never was one, that the cosmos, to use that word, has always existed. That's very appropriate. You mentioned at the top of the program that I worked with Fred Hoyle. I don't know if people know that he died a couple of days ago. And this was one of his ideas, the idea of an eternal, expanding, infinite universe within which what we call the Big Bang was just a local event. So there are real possibilities that people investigate and probe. But, of course, we'll never, unless we build that time machine, we'll never be able to go to the Big Bang and see for sure which idea is correct.
Professor, I'm unable to grasp the concept that it has always been here. Now, if it's always been here, we sort of understand, I think we understand, don't we, by measuring quasars, how quickly everything is moving away from everything else. By now, if it's always been here, we should have long ago had nothing but black space about us, shouldn't we?
No, what we're saying is that there's a something that's always been here, but that our Big Bang is a bubble within that something. It's like if you have a bottle of fizzy drink, and you unscrew the top and suddenly all the bubbles appear. It's in a sense, the fizzy drink has been there forever, as long as it's been standing in your fridge anyway, and then the bubble appears, and that's the Big Bang. That's our universe appearing within the something that's always been there.
Huh. So then maybe we are nothing but a bubble inside a glass in some...
Well, who knows? Then you are talking beyond physics. But that's where we get back to these ideas you mentioned earlier about different laws of physics, because if you've got a literally infinite universe in both time and space with no beginning and no end,
yes.
Then within that there are all possible bubble universes going off, and there will be other universes with different laws of physics. And then that's one answer to this question about why our universe should seem to be just right for life. The idea is that there'll be many universes with different laws of physics, and the only ones in which there's going to be people like us wondering about it are the ones where the laws are just right for people like us.
Yes.
So it's then much less of a coincidence if you've got a choice of universes that we should exist in one that's a good one for life.
Well, okay, but if there are literally, and to us at least, an infinite number of these universes, as there appear to be almost an infinite number of stars, suns in the night sky that have planets no doubt revolving around them, we're proving more and more, then whether we're talking about jumping across to another bubble or we're talking about going to some star system far away, is it not almost inevitable that in both of these there would be life would be common? Even if it was scarce, it would in essence be common.
Yeah, I know exactly what you mean. If you've got in our galaxy there are a couple of 100 billion stars, and there are at least a couple of 100 billion galaxies, and if only 1% of them, which is scarce, have got life, then there's a lot of life by human standards. Absolutely, I think that's very much my view, and I've written about that in my book Stardust, which I think we talked about a year ago. I was on the program when it came out originally. And the materials for life are very common in our galaxy, the raw materials in space, the complex chemicals that are the precursors to life. And I think it's very, very likely that life is common in the universe. But the big question is whether intelligent life is common. And that's much harder to see, because there do seem to have been a lot of a chain of events, a long chain of events, which led to us emerging as intelligent life. And we've been around for, by the most generous estimate, 1 million years of intelligence on Earth. And the life on Earth goes back nearly 4 billion years. So if it takes all those billions of years of non-intelligent life before you've got intelligent life, then intelligence might be very rare indeed, even if life is common.
How probable is the hypothesis that there is no other intelligent life out there? People rarely talk about that probability, but it's along with everything else, it's got to have some probability, right?
Yeah, absolutely. And I think the simple answer is that the numbers you're talking about are so huge that even if the probability is very small, that adds up to a certainty that there is some other intelligence out there in the universe.
Well, if you believe, Professor, as you do, then would you say that your work supports SETI's continuing search for extraterrestrial intelligence, whether it be by radio near the hydrogen frequency or with the new light experiments?
Very much so. The really exciting thing about the discoveries of planets that you've mentioned is that there are so many. I mean, every time the technology improves, we find more planets. And the latest ones, the discoveries that have been coming in the past couple of months or so, are planetary systems that are much more like our solar system. The first ones that were discovered had big planets, bigger than Jupiter, close to the stars, close to their parent suns, which are very different from our solar system, but they're the ones that were easy to find. The techniques have improved, and we're now finding planets about the same size as Jupiter, orbiting about the same distance from their suns, but Jupiter orbits our sun, and in more or less circular orbits. And that suggests that we've got planetary systems very much like our own, with big planets far out and almost certainly small planets close in. And I think the whole SETI program has received a huge boost from this, and it's probably the most cost-effective science you can imagine doing, because it's only got to work once. And it just transforms everything about human society. Is it
not, Professor, almost inevitable? We've got a little time delay between here and England. Almost inevitable that obviously we're seeing the big ones, because as our technology improves, we see the big ones first.
Absolutely.
Planets are hard to find, but is it not almost inevitably probable? I'm not sure that phrase works, inevitably probable, but certainly probable that there are smaller planets, ones very nearly the size of ours, and again, inevitably at about a point from whatever sun they might be near, that would support conditions and climate similar to that which we have here on Earth.
Yes, I agree entirely, and there's a very exciting proposal, which is very likely to get funded, I think, for a telescope to be put in space, which would be able to detect other Earths out to quite a reasonable distance. So we may actually, within 20, 30 years, I mean, well within a human lifetime, we may actually be able to have images of these other planets, the size of the Earth, orbiting nearby stars. And if you can do that, then it's a very simple trick using spectroscopy, you know, the different colors of light from different elements and so on. It's a very simple trick to see if those planets have got carbon dioxide, water vapor, oxygen in their atmospheres, which would be signs that there is life there. So we could know in a very short time if there are planets with life elsewhere in the universe. And from that, obviously, then the next step is to look for intelligence.
Have you considered the impact on our world of contact?
Well, I personally, I sort of shy away from it. It's rather like the way I shied away from getting involved in the politics of global warming and climate change. It needs experts to worry about this. But there are experts, as I mentioned, psychologists, sociologists. There are people who do seriously consider these problems and what the effect would be, whether if a contact is made, it should be announced to the public straight away, or somehow people should be prepared for it.
If, Professor, you were the one to, perhaps with others, make this discovery, you would have thrust upon you the responsibility of deciding what to do with that information. What would you do?
My instinct would be to tell the world at once, because I've got great faith in human nature, and I think that although it's correct for people to worry about the problems, I think that people would rise to the occasion, and it would be an uplifting experience for everybody to know that we're not alone, in the same way that the pictures that came back from the Apollo missions showed us the Earth as a little oasis in space. And that was a profound experience, which was basically beneficial to humankind. I think knowing we're not alone would be equally beneficial.
Well, I guess it would depend. If what we found was 100 light years away, I think people could handle that news. If what we found was, for example, much closer, let's say we detected a spacecraft on the way or something like that.
Oh, yeah, no.
That would be a bit of a different sort of thing to break to the public, wouldn't it?
Sure. No, I was thinking in terms of making contact with life on a planet orbiting another star, not somebody sort of knocking on the back door of the solar system. I think in that case I would gladly hand over the responsibility to the government or the United Nations or whatever the appropriate body was to decide what to do next.
And you'd be comfortable that as you handed it over to the government or the UN, they'd handle it just fine?
I think so. I mean, maybe I'm a naive optimist, but as I said, I've got pretty good faith in human nature, and I think that these kinds of bodies are run by people who are, to put it at its worst, well-meaning. You know, they're not going to go out there and try and do something evil and unpleasant with the information.
Well, there are many people who believe that these UFOs that are seen, these strange craft that we believe, that our military roundly denies, and I suppose yours does too, because we do most stuff in lockstep, that really we are being visited, and we've done some rather nasty things. We've, frankly, some people believe, shot at these things, which wouldn't seem like the brilliant thing to do, would it?
No, it wouldn't. And this is, I mean, something like that could happen by accident. I can imagine that, you know, an individual pilot of a fighter or something might get carried away and do such a thing. But I don't think anybody is going to do that on purpose at the level that we're talking about. And I think, you know, for good or bad, whether you think it's a good thing that we spend so much money on the military that we do have very efficient military systems with very efficient command structures. And I think the kind of people who are trained to fly the kind of high-performance aircraft that would be involved in such encounters are disciplined enough to obey orders and to not shoot at people if it's likely to do more harm than good. And I think that we have nothing to worry about in that sense.
Well, since I
don't believe there has been a contact yet.
All right. Well, since you now have an opportunity to address those who would make that decision, should it occur, I wonder how you would advise them. For example, by that I mean, wouldn't it seem likely that anybody or group of people who got here would have achieved interstellar travel, and so they would have technology certainly in our lifetime anyway, that would so eclipse ours that if we did shoot at them and they were to shoot back, we would really hate what happened.
I'm sure that's true, but I think anybody who's got to the effort of making the distance across space from stars is going to not be trigger happy. They will have encountered what they would regard as primitive civilizations before. They'll know how to set about these things, and they won't be making that kind of mistake. It doesn't make sense to imagine that people are going to come here, beings are going to come here bent on conquest. The distances involved are too great. The effort of traveling across space is too great. What we would get would be some kind of scientific mission that would be interested in information and making contact and exchanging cultural ideas.
Or perhaps only observation.
Or indeed. I mean, that's the most plausible case, I think. The people who argue that we may have been visited or are being visited by other beings who merely want to observe us and are perhaps waiting for us to, in a sense, grow up, and stop being so trigger-happy ourselves before they're willing to make contact. I think that's the strongest case of all the people who do believe that we have been visited already.
And then that would then be the strongest case for the ufologists who say, look, yes, one has not landed on the White House lawn, and it's not likely to because we are being observed. So on occasion, when we really do see craft that cannot be explained, and certainly we know that a certain percentage of these sightings absolutely cannot be explained, that it's observation. That's a pretty strong argument for their case, isn't it?
It's a very good case, yes. I mean, I don't go along with it myself. I lean towards the view that these events probably could be explained if we had a little more knowledge than we have. After all, we've only been a scientific society for a couple of 100 years, and there's a long way to go yet before we understand all the natural phenomena in the universe. But I do agree it's a very good case, and I wouldn't be overwhelmingly surprised to be proved wrong on that point.
Would you be overwhelmingly surprised that contact would occur during your lifetime? In one way or the other, whether it be communication or a physical contact?
Well, we live in a very interesting time because we've just started to broadcast to the universe. For about 50 years, we've been making TV signals which spread out into the universe. So in that sense, it would not be surprising. I mean, I'm lucky to be alive at the time when that's happening. But in terms of human civilization and technology, now is exactly the time when you would expect to be visited if there are beings out there monitoring the Earth, because they've had 50 years to notice that we've reached the level of technology to produce signals that can travel through space.
Professor, we are at the end of our time. You promised an hour. Actually, I dragged you out to an hour and a half.
Yes, I have to get into work.
All right, we've got to do it again. Professor,
It'll be a pleasure.
All right, we'll be calling you. Thank you, Professor, and good night.
Good night.
And I'm Art Bell, and this, of course, is Coast to Coast AM. Top of the morning to you.
I can't survive.